All right, now that we have our first command created, we need to go ahead and get our command manager up and running so that we can test it out. So what do we need to do? Well, we need to go to the whiteboard. We need to talk about it for just a second. I'm going to go ahead and bring up a new whiteboard. All right, so we're now looking at the creation of the command manager. So just like we took a look at the base command class, let's take a look at what's required in our command manager. Well, we said we're going to need a list of all of our commands. So basically this is going to result in us needing a static list. Check out how we do this, of commands. Actually, let's take out that S. I'm just getting a little carried away there. There we go. Now, think back. Think about your training. Every single command that is an extension of the command class is still a command. So the clear command that we created in the last video is still of type command. It just has a few extra capabilities. So keep that in mind. So by creating just a simple list of commands, we can hold all of these varying types or different types of commands. All right, so a list of commands, and we'll call this something like the command list. All right, what else are we going to need? Well, we're going to need a static constructor that's going to create this list as well as handle the registration of commands. So a static constructor and what is he going to do? He needs to create the list and he needs to handle what we are terming register commands. So what does this register commands look like? It's really simple, actually. Basically, all we're going to do is take the list, so our command list, and add to the list, so .add, a new, and then whichever type of command it is you're registering. So let's just say that we take the command clear, and of course, it has a public constructor that requires you to send it the name of the command. So what is going to be the name of the command? This is going to be the name that we are expecting the user to type into the console. So in this particular case, we want them to type in the word clear. So this command's process will respond to somebody typing in the lowercase word clear. So close that, and we'll close this, and we'll terminate. This is how we will register commands. So there will be one line, command list.add, for every single command that we have. Okay? Now what else are we going to need? Well, the command manager is going to need its almighty process command method. So a static process command. And we've already taken a look at this. We're going to use what we started out back in the architecture video, where we were talking about an overview of the whole command system. It's going to take in a string called line. And inside this method, what are we going to do? Well, we're going to make sure that the user actually types something in so that we have at least a single command. So there must be at least one argument. And then, or not one argument, but one element in the array, because remember, we're going to be using an array, a string array, inside of the process command method. As long as we have at least one element in the array, we'll then simply walk through all of the commands in the command list and query each of the command's names against the text that was sent in as the command, the first element found in the array. And if we simply find it, we'll call upon that particular command's process. And if we don't, we'll say command not found, and that's pretty much it. So Logan, let's go ahead and jump over to Visual Studio and see if we can start putting this together so that everybody will get a better picture of what we're talking about.
All right. Let me jump back over to the Command Manager class, and let's begin with all the changes we need to add. First is going to be the static list of commands.
Okay.
So I need to jump up back above the command or the process command method, where I can define a private static list of type command, and we'll call this our command list. I'm making it private because does anything actually need to see that the command manager uses a list? No, it doesn't have to know if we use a list or a switch or whatever.
Exactly.
So this is going to be a private static list for the command list.
Okay. So now let's go ahead and get our static constructor into place so that we can actually create that list.
All right, so we'll have a static command manager for our static constructor. And the first thing we'll do in here is initialize the command list. So that will be command list equals new list of commands.
Beautiful. Now, our first registration, and let's go ahead and break these up. We'll throw some comments in there. Our commands are going to break up into 3 different categories. We're going to have viewing commands, creation commands, and editing commands. So clear is going to obviously be a viewing command.
All right, so let's take a look at registering our first command. This is going to involve accessing the command list, telling it to add a new item. That item is going to be a new command. And more specifically, this is going to be a command clear class that we're creating. Now, all commands take in a string for the command name, so we're going to bind this command to the string clear. So that clear is the text that needs to be used to invoke this command.
Okay.
So we'll end off the parenthesis for the command clear, and a final parenthesis to end off the command list.add.
Okay.
With that, we can simply terminate that line, and that takes care of the registration of the clear command.
Okay, and that also, for now, wraps up our static constructor. So let's go ahead and turn our attention down to the process command method. And inside of here, what do you need to do? Let's see. Well, first of all, we're going to need to split out, just like we're doing there, our commands into a string array, and we're doing that. From there, we're going to need to verify that we do indeed have one. So all we need to do is take out that switch methodology that we were talking about earlier, and populate it with our own functionality that's going to utilize this new object-oriented approach that we are putting together. So,
all right, let's begin with a type of output buffer. Let's
okay.
declare a variable that we can use to store any output that a command may give us.
Okay.
So I'm going to define this as a string, and we'll call it output, much like we did inside of the actual clear command itself. Now I want to initialize this to null here, and we'll get into using that after we've actually retrieved a command from an actual running command.
All right, so the next thing we need to do is, well, as we've said several times now, loop through all of our commands and see if we have a command in the command list that matches arguments sub-0. So the very first element in the string array that we have got.
Okay. For this loop, I'm going to use a simple for loop because the index nature of that loop will be useful to us later in order to tell if we found a command or not.
Okay.
So I'm going to begin a for loop. With the for loop template selected, I'll hit tab twice to invoke that template. And that way it's simply more convenient because I would like to use the variable I as our index variable. So all I have to do is tab over and change length to arguments.length. So as long as I is less than arguments.length, we continue looping. And that takes care of the structure of our loop.
Okay, hang on one second. Do we want to do arguments.length, or are we looking through all of our commands?
I'm still stuck on the array.
That's okay. Yeah. I've got you back. Yeah, we need to loop through all of our commands that are in the command list.
Right, we're looking at this instead.
That's right. So what he needs to put in there is command list.count.
I think it was the fact that length was already given in the template, and that's what threw me off.
I got you.
So what we're actually looking at is command list.count, because we wanted to go through all of the currently registered commands and look for a specific command.
Excellent. Okay, so now what we need to do is, well, just simply check to see if each command that we're currently looking at's name matches argument sub-0.
All right, so that would be a matter of looking into the command list, and since we have an index value pointing at a specific element inside of that list, or a specific item, I'll simply plug I into the command list, so we access that item, and then we want to check its command name property.
Okay.
We want to see if that command name property is equal to arguments sub 0, because obviously the first argument is going to be the name of the command itself.
That's right.
So that's the check we need to perform.
Okay.
We'll block that in, and if this is indeed true, that means we have found the command that we wish to run.
So we're going to need to call upon that particular command's process, which we know the process method is going to return a string back. So we can store the returned information into the output variable that you created at the beginning of this if section, or the if section above it, the main one.
All right. So we can say that our output value is going to be equal to the given command, which is command list I, so the command that we're looking at, dot process. And what do we need to feed process? Well, the overall arguments, which we already have in arguments. So the argument string array is what gets passed.
So that means, yes, the process method will once again receive the command along with any parameters. But that's okay, because we know once we get into each of the commands and we're taking a look at the arguments, it's real convenient because we can say argument 1, argument 2. We can ignore argument 0 because argument 0 is the name of the command. So once we're inside given commands, it's very convenient. Argument 1, argument 2, so on and so forth. All right, very good.
Now, after we've found a command, we can make the system a little bit more efficient by breaking out of the loop. Because if we've gotten to this point, we know that we have found the command, and there is no reason to look for any more commands.
That's right.
So we can simply break out of the loop.
Beautiful.
All right, and I believe that's all we need.
That's
for
very
the
important to make
itself.
sure you guys grasp why we are doing that. There's no reason after we get finished executing a command, if there's 20 more commands in the list that we've yet to loop through, there's no reason to continue looping through all of those commands, because you should not have commands with duplicated names. Okay?
Right. Now, the next thing we need to address is some kind of mechanism that will allow us to detect whether or not we found a command. We know that we're inside here, but we want to come up with a mechanism that's more efficient than storing an additional variable to tell us whether or not the command was successful. Due to the nature of the for loop, with the fact that we have an index variable, we could use that value to tell whether or not we ran past the end of this list.
Mm-hmm.
Now, in order to do that check, I'm going to need to make the variable I visible outside of this for block. And to do that, what I'll do is simply take the declaration of our index variable, and move it outside of the for loop. And then, of course, leave the blank terminator to indicate that there is no initializer for the for loop itself. So we initialize I ahead of time, but still use that value to control the loop.
That's right.
The benefit we gain from this is that after we have finished this loop, we still have access to the value stored in I. That means we can tell how high the value in I reached. Did it reach past the end of this list? Because if you remember, the way a for loop works is that after an iteration is complete, then this value I is incremented before the check is ran once again. So that means value I, let's say that we had run for the last item in the command list. We do the loop, we come back around, then we set I to 1 past the end of the list. But this check makes sure that we don't execute in that case. So that means if we got to the very end of the list and did not process any commands, we're going to exit with I being 1 past the end of this list.
That's right.
Otherwise, if it's 1 less than the very end of the list, then we know that we found our command. So let's do a check based on that, so we can set up 2 different scenarios. One to show the output if it worked, or something to show an invalid command. Because if no command was found for the given text, then that given text was invalid.
That's right. So we could start out by just doing a simple if statement where we're going to check to see if I is less than command list.count, which means if that's the case, we found our command.
So if it's less than the overall count, we do indeed have our command. So we can do something like just output the given output as a console write line. Now, I don't want to just write out a line every time a command is successful, because we have the possibility of something like the clear command, where if it worked, it's going to have no output. So echoing out the output is actually going to make an extra blank line. So we'll do a simple check to where if a command didn't return anything, we don't actually show that. So this is just a check to see that if the output length is greater than 0, so basically if there are some characters held in output, then turn around and tell the console to write out the given output. Alright. Now, if I was not less than the command list.count, that means we ran past the end of the list, or in other words, we ran out of commands to try. So we have an invalid command scenario. So let me block in an else. Inside of here, we'll simply write out to the console that this was an invalid command. And maybe something like that.
Okay, that's good enough.
And with that, if everything works, I believe that's all we need for the core of the command manager.
So now it's time to go ahead and tie this in to the overall program and test it out.
First, let me build with this command itself, or the command manager. Everything seems to work, so if everything goes according to plan, then we should have the clear command registered in the commands list, and then the commands list invoked whenever we process a command.
Okay. Actually, everything is tied in, thinking about it.
Yeah, because we've already we had the simple mock-up version running on a switch statement, which is why back over in main we have our while loop set up. So none of this has changed, and that goes back to your diagram of the command manager being a fuzzy cloud, because we don't need to know what happens inside of it for it to actually work.
That's right, and here that's really cool. We were able to show two different implementations of a command management system, one using the switch method and the other one using a series of registered objects. And we were just able to pull out the guts, plug in new guts, and yeah, everything should work. Let's go ahead and find out.
All right, well, obviously things like sphere should not invoke command, or
should be an invalid command. Ooh, invalid command.
And it is. So what about the clear command?
Wow, it worked. Fantastic. All right, well, that's everything that we needed to get the basic command manager up and running. Now, to be honest with you, at this point it's just going to be a matter of registering every new command that we create, but outside of that, the command manager's done.
Right, yeah, the command manager is fully fleshed out and the engine is indeed working.
All right, so with that will wrap up this video. Thanks a lot.